Hello everyone, I'm Pedro. For some reason Stefan keeps inviting me to come here and present, but since there's pizza and beers, I keep returning here. I will talk a little bit around Pentaho. I will not focus on the technology, but I will try to talk a little bit more about what we are seeing in the market in terms of trendings and how people have been trying to address those problems, and also what it means to be part of Hitachi Vantara and then part of Hitachi. So this common headaches slide has a lot of things that pretty much could be seen on a lot of slides of these presentations if they were made like on the previous years. But I think there are some important topics that have been appearing that weren't there. So the second one, I believe it's something that we've been seeing appearing a lot, which is the need to handle this hatch to on-prem to cloud infrastructure. A couple of years back, I guess on the first meeting, everything was done on-prem. Last year, 2 years ago and last year, everyone was trying to move to the cloud. And now all of that is being morphing into something different, and I will address that a little bit. Something that has been also a huge concern on the latest years, and I guess in general, in here especially, you have been seeing that much more than everything, than the rest of the world, is everything around governance and regulatory compliance. GDPR did have an effect. Hopefully some good things as well, but it forces us to think differently. And this is something that we all know. We have a lot of data, but there are a lot, using this kind of leaky pipe concept, there are a lot of areas that prevents us from taking the full potential out of that. And the value that we take from data doesn't amount to the amount of data that we have available, and it's important to try to understand how to maximize that. This is something that we've seen a lot. So we had everything kind of on-prem using the data lakes or data warehouse. All of the models that we've seen pretty much stabilized since the concept appeared. In the 80s, I guess, since Kimball wrote the Bibles that a lot of us still use today. Then on, I guess, 4 years ago, with the AWS advent, now Azure and all the cloud vendors, everything started moving to the cloud. We no more heard those things of, oh no, I want to really control my data. Screw that, just have all my data, let's put it to the cloud, I don't want infrastructure anymore. But that's taking a step back. More and more people are starting to see that not only from a cost perspective, which is actually a surprise. Sometimes it's much more expensive to have things on the cloud, but for different reasons, either optimizations or data locality, or even things like local governmental data privacy, we need to have a better control that just having everything on the cloud doesn't help. So today, we do need to have that kind of mix between cloud and on-prem. And now that if we also throw the IoT needs to the mix, we start having all of that edge variable playing an important part. A lot of times we have to use those edge devices as the sources of data, where before our sources of data were ERPs, CRMs, regular databases. Now we have actually real devices producing data, computing and storing data, and we have to manage all that. So I've been around since for the last 10 years, and right now I'm fortunate enough to actually have a marketing team helping me with some of the slides, which is a good thing. The bad thing is that I have a marketing team helping me with some of the slides. I have no idea why this thing is here. I also have no idea what this thing is here, but someone actually thought that putting things that everyone knows would be interesting on a slide. And it's also always great to put random numbers referencing some Harvard study with no context at all, but yeah, whatever that means. and ending up with yeah, right. So, skipping this part, there are really some interesting use cases that really do the right thing, which is puts the value not on the tool itself, but on what we can achieve with that. And here are some use cases that are particularly interesting. So BT is using Pentaho, and they were able to reduce cyber threat detection time by analyzing a lot of unstructured data from weeks to seconds. I'm really not sure if in this case we should be proud of allowing them to now be able to detect these things in seconds, or if BT should be embarrassed to take weeks to solve that challenge before. But anyway, it's something that we can be proud of. So Carfax is an example that we also like to do. Carfax, for the ones that don't know, I didn't know them. It's I think they operate worldwide, but it's mostly in the US and Canada. And basically they collect and track all vehicle incidents throughout all of the vehicles that are in there. So but basically the goal, the services they provide is that if you want to buy a second-hand car, you go to them and you're able to get the entire history. And that proves at least that would have saved me from buying a few cars that I bought that actually had a couple thousand kilometers more than I thought. And they use a great balance of structured data for all the reports that are available, but also unstructured data and digital information for things like repair guides and things like that they have to scan and keep for X amount of time. So they use things like the normal ETL to get that structured data, image recognition, and a lot of storage involved in storing those different images. And like I said, as you know better than anyone, the regulatory requirements for storing this data changes drastically depending if we're talking about US, Canada, or Europe. Stio is a great example of an OEM. They have a spectacular, they usually present in here. I think they have presented last year, if I recall correctly. I had no idea we could do that with our product, to be honest. Those guys are doing amazing stuff, and they offer an OEM implementation, and I believe they sell it as a service. I don't remember exactly of the model, but they are able to really increase the productivity for their own customers. Caterpillar is a kind of a more classical example in terms of managing data, but they use a bunch of prediction algorithms, and they were able, we're talking about improving the reliability and effectiveness of ships, and they were able to save pretty much, I think, $750,000 per ship per year. And one of the interesting data points that we got from that project is that they were able to increase the effectiveness of the ships, not by increasing the time interval in between repairs and cleanings of the ship's hull. I believe it's hull, that's the bottom part of the ship, but by increasing the frequency, which was completely against what they were expecting. And the reason for that, once you actually know the reason, becomes pretty obvious. The fact that it got so much dirt attached to the ship's hull required much more fuel and it became much less efficient. So stopping the ship more frequently to clean it ended up increasing its effectiveness and lowering the amount of damage and incidents that were attached to that. So this is some examples of how people kind of organize and map these at a very high level. Usually, structured data follows the bottom part. Ends up in the data warehouse. We follow the normal rules to handle that, and it's usually accessed by the normal BI and reporting ad hoc or not to do that. And structured data plus a combination of the information that we have on that data warehouse allows us to put much more customized analytics engines on top of that. And then now we have, it's not new, but mostly given these IoT scenarios, all the streaming data that can be used for a lot of things. We have the generic data science term, but we usually try in as real time as possible to get insights of that and act immediately to it. But I guess one of the learnings that we got from all that is it is a mistake to try to put all the, especially the streaming and the unstructured data, and store it as we handle the normal structured data. It requires a different approach. We should not try to funnel it through the classical ways of doing things. So this still holds. The classical data warehouse architecture, at least if every time I see someone saying that the classical data warehouse is dead, it's bullshit. It's not. It's just not the solution for every problem, like I guess in the past, a lot of us, in the past effectively, it was enough. Today it's not, but it's still a really, really valuable set of methodologies, and we have amazing tools out there to make this thing work. So if you have a good data warehouse in place, don't throw it away. Complement it with other things on the side to be able to manage the unstructured and streaming data, which is adding a layer on top of that. So even if we use a Hadoop cluster, Hadoops, or whatever kind of big data infrastructure, whatever kind of analytics DB or SQL, no SQL, what we try to focus on, and in here we'll start seeing some tooling and terminology appearing there, is simply because what we've been trying to do for a while is basically use Pentaho as an orchestrator to leverage the best tools for the job. And we've been seeing that those tools change because the needs and the requirements have been changing a lot. This is a combination that we see appearing a lot of times. So still maintaining the combination of the data warehouse and the normal data marts, and combining that with big data stores, and with NoSQL solution. Now we're seeing some extra layers like graph databases and things like that basically allows us to use those tools depending on our requirements. And this is something that we see once we have that extra layer. When we start counting with streaming, we see this kind of high-level architecture to get a little bit more complex. So and here's where all the different cloud technologies help a lot. For instance, in AWS, things like Kinesis also allows us to do a lot of that, but it's easy for one to start getting scared. I definitely cannot keep up with all of that, with the amount of tools and techniques and technologies. So at least having something that allows us to tie in the dots in between all of these approaches allows to isolate our problems in kind of a almost like that. It's not a microservice approach because we're talking about an architecture of a solution, but the principle is the same. Also, one of the things that's really fundamental to understand, and I've seen a lot of projects fail for forgetting this very basic rule, is let's just make sure that we're solving the right problem for the right person. Trying to serve some line of business user is very different if we're trying to give information to a CIO, to a CFO. So the way we do things really depends on how we should kind of approach the project. I know this sounds pretty obvious, but it's amazing the amount of time where we just start implementing things and forget about that. Marketing slide. Obviously, one thing that we've also seen is that technology alone doesn't serve it. If we don't know what we're trying to do and have a support on that, and obviously this is the slide that services people kind of copy-pasted into here, be sure to talk about us. All projects will fail if we don't know what we're doing. These guys, people from it-novum have been knowing that for a while and have done a lot of that. Only when I got to this slide, I realized that all of those boxes that I thought were kind of having a glitch in there, they kind of make the word fast on the first one. Martin really likes these kind of stuff, right? just so lame. Anyway, so what happened to us? So we've been Pentaho company that no longer exists and has been going through a transformation. We're now part of Hitachi Vantara, and we basically have access to a much bigger set of elements in the portfolio. Marketing side, blah blah blah. We'll call these I don't understand these things, but this is an important thing. By joining Vantara, well, it was not by accident that the old Hitachi data systems and Hitachi got Pentaho, because they lacked a good component on the portfolio for doing data integration and analytics. But there's a lot of other components. There's good examples there in the Solution Expo. Solutions for video intelligence, IoT platforms, streaming data, object storage, content intelligence, a lot of solutions on the infrastructure side that Hitachi has been really strong at. What we are now doing is trying to, if I want to kind of simplify it, break these different products into reusable components and then reassemble them in a way that they can tackle a lot of those new scenarios. I mentioned, for instance, that most projects today are a combination of structured data, unstructured data, and streaming. Pentaho is not naturally, Pentaho does not excel in unstructured data. We can do it, but it's not its strongest. It's really good, the data integration side of things, is structured data. The Hitachi Content Intelligence was made for unstructured data. So, the kind of things that we are doing from a product perspective is trying to integrate and bring together these different elements to offer us kind of a seamless and well-integrated experience. It's something that with a portfolio this big and within a company with 8,000 people, it takes time, but we're getting there. We're much bigger, we're much better now than we were one year ago, but we're really seeing, and once again, we have some good examples in there, good examples of getting these things playing together. And one of the things that we're trying, getting all of these elements playing well together requires a method, a standard methodology in how we approach those challenges. So throughout what we do, we always we use what we call the SEAM methodology or stairway to value, from the conservative buyer to the visionary buyer, where we avoid thinking about just features and specs, but we try to look from the point of view of what the customer is wanting to achieve in each of their areas, and then try to make sure that we change our portfolio to adapt to that. So HDS is, Hitachi Vantara is like 8,000 people, between 5 and 8,000, and one of the main and most important elements that will drive our success, because obviously we're going to succeed in all of these, and by Apple at the end of this journey. We're backed by this Japanese monster, which is Hitachi. It's, they say 300,000 employees, I think it's twice that or whatever. But there's a lot, really a lot of innovation going there. And it's very, very different to work between, the difference in between an American company and a Japanese company. For the Americans, the world will end at end of quarter. The Japanese guys think 3, 5, sometimes 10 and 20 years ahead. So it's, at least from an European point of view, I actually connect better with the Japanese style of thinking than with our fellow Americans. That completely drive me crazy. So, Pentaho 2. I would go very, very quickly with this because I don't want to turn this into like a technical presentation, especially with the ends focusing a lot on the data, on 8.2 on the data integration side, which I believe is correct. So, these are kind of the main themes of 8.2, and you'll see that this goes together with what I mentioned before of trying to leverage the rest of the portfolio. So, access, integrate, and process wider variety of data sources with an integrated portfolio. That mostly means things like streaming and unstructured. Orchestrate models and collaborate with data scientists, has mostly to do with machine learning and data science algorithms. And then, whatever we do, whatever project we do, it needs to run, and it needs to run at scale. So, every year we try to make sure that we move a couple of steps up the ladder in making Pentaho a really, really enterprise scale product. So in here, one of the things that we really want to do is leverage what our own team is also very good at. And this is the integration with the HCP storage area. It's now possible to really leverage that part, and we've seen that from a cost perspective. Like I mentioned before, people are going a lot of times back from the cloud to these kind of infrastructures for some of the data and choose selectively what to store. And having this kind of storage in-house allows us to have much fine-grained control of data locality, retention, and policies. Like I mentioned, Carfax uses this a lot to manage all of their unstructured data. And I think I went through this a little bit. These are some examples of use cases where having control of this data layer brings advantages. In healthcare, I mean, if we start thinking about storing to a longer term, all of those things like MRIs, scans, and all of that, it's not something that it requires us to think into the challenge that we're fixing. Security is obviously a very big one. Retail the same. So every time that we just think about video, live or archived, or high definition images, it's an entire new ballpark that definitely cannot be solved with normal data analysis. Amqp support, so we've been adding to the supported layers of these streaming protocols. We have Kafka, MQTT, JMS. Amqp is something that adds to the layer of supported technologies that we need to have as we want to be cloud agnostic. So, and this is another one. We've been increasing the support of MapR. 2 years ago, no one was, this is more or less, no one was paying attention to MapR, and we actually seen that changing recently. MapR is getting more and more usage, so we've had an extra support for MapR. In terms of collaboration, we try to pay attention into how the data scientists were working. And there is no, it was clear for us that we will not try, it's impossible to try to tell a data scientist how they should work. You cannot do that. They live in their own world, they're amazing at what they do. So what we try to do is understand how they work and try to help on the productization and systematization of the models that they create and they develop. So this is not a tool for the data scientists to use on a daily basis. It's a tool for something that once we want to repeat and reapply that in kind of systematic or even production environment. And that includes managing and executing models in Python and R, and also as an example of Python to orchestrate, and even integration with Jupyter Notebook. So in here, more than try to have okay, here's how you should work, there's a couple of options that that can be used depending how the data science teams work. I think Ken will talk more about integrating data science with Pentaho later, and I think there's some booth in there where it shows some of the capabilities that can be done here. I'm running out of time, so just keep forward. So we've realized a while back, I mean, it's kind of obvious that just running with Pentaho data integration on a single computer is something that does not scale at the need that projects require. So the integration with Spark is something that we've been supporting for a couple of releases, and we've been improving with that every release. So the goal is to have a transformation and basically decide this is something that can be used, executed locally. This is something that we should just spin up to the cluster and leverage all our computing power. This is probably the single most requested feature on the last decade, which is the support for Open JDK, and it's finally now a supported platform.
Last slide.
Okay. So for big data, add extra features on security and encryption, some stuff on transformer monitoring, Jens will go through it, JSON enhancements, Jens will go through it, and this is the last slide. And that's almost, well, I did run out of time.
You're great on time.
Surprise. Okay, thank you. I don't know if there's any questions.